morning from Hamburg. My name is Thomas Ernst. I'm Field Application Engineer at Trinamic, and in this session we want to talk about reliable positioning with Trinamic's evaluation system. How to move to a position. First, we set up our system. Now open up your TMCL-IDE and the positioning mode. Enter a target position and press play. That's it. Goodbye. I'm just kidding. When we talk about positioning, we talk about position, of course. And maybe we talk about speed. But very important, we're talking about preventing step losses. What does this mean for your application? Of course, you can ensure reliability by using an encoder. But for a lot of applications, this is not necessary. Stepper motors can be very precise and safe when they are controlled the right way. In order to achieve this, we need to find a suitable velocity profile which your motor can always follow within your application and without the risk of stalling. How can these ramps look like? The simplest ramp is a trapezoidal ramp with an acceleration, a running and a deceleration phase. This is how the firmware-generated step direction ramps within our evaluation system look like. The next level is a 6-point ramp. What's the difference? We know from a certain point the torque reserve of the motor decreases with velocity. We can use this fact to accelerate very fast from the standstill and decrease the acceleration at a certain velocity to ensure enough torque reserve. This behavior can be the same for the deceleration phase. Like this, we will reach your targets faster without the risk of losing steps. All of our new generation chip products with integrated motion controllers support 6-point ramps. For example, the TMC5130 or the TMC5072. Or do you want to move heavy loads or go even faster? You can push it to the max with S-shaped ramps. Using S-shaped ramps, we ensure to go with nearly highest physically possible acceleration for your application. How does it work? To put it simple, we need to avoid salient points in our velocity profile to decrease jerks in our system. Our TMC457 and TMC4361 motion controllers allow you to define continuous S-shaped velocity profiles to do this. How does this look like for your evaluation? Basically, it's the same for all of Trinamic's chip evaluation boards. Let's do this with the example of the TMC5130. We already launched our setup and did the first movements with one of our out-of-the-box tools, the position mode. So previously we moved per default with the trapezoidal ramp and some recommended initial values for acceleration, deceleration and velocity. Now let's try this for a 6-point ramp. In the visualization of the velocity profile, we can find 7 points of interest. Start. Thanks to the maximum torque reserve, it may be possible to immediately jump to a certain velocity. Acceleration 1. Now comes the first acceleration phase between the start velocity and velocity 1. This acceleration can be still quite high, because as the velocity is low, we will still have a lot of torque reserve. Acceleration 2. With velocity 1, the second acceleration phase starts. Here we can adapt the acceleration to the torque conditions at this velocity range. Running. With the second acceleration phase, we will reach travel velocity. Deceleration 2, deceleration 1 and stop follows the same principle as the acceleration phases but in the opposite direction. With these parameters you can optimize the settings for your application. The hardware ramp generator produces smooth ramps and sticks to acceleration and deceleration values even if you change them on the fly. Once the ramp is set up, we can enter a target position and press play again. The position mode has some more nice features I want to show you. Move by. This means the motor will move this number of steps starting from the actual position. Alternating. If you furthermore set this tick, the motor will repeatedly move this amount of ticks back and forth. Default. With this option you can reset to the suggested default ramp values. Load. This button allows you to read back all relevant parameters from the chip into this tool to update it after further modifications. Info. The info button shows you the TMCL code for setting all relevant parameters. You can use this code to integrate it into your TMCL PC procedures. For even more performance, we recommend to use a possibly high microstep resolution to avoid resonances in your system and to thereby have more torque reserve for your movement. Our drivers typically support 265 microsteps per full step, and even interpolate from lower resolutions to 265. My name is Thomas Ernst. Thank you for watching, and as we say in Hamburg, tschüss, bis zum nächsten Mal.